When you think of NASA, your mind probably pictures vast stretches of space, astronauts floating in zero gravity, and the exploration of distant planets. It conjures images of space shuttles blasting off into the void, high-tech satellites orbiting distant worlds, and rovers traversing the rocky surfaces of Mars. But what if I told you that NASA, the organization synonymous with space exploration, is also diving deep into the oceans of Earth? Strange, right? Why would an agency dedicated to unlocking the secrets of the cosmos be exploring the depths of our oceans? What could they possibly be searching for beneath the waves that rival the mysteries of outer space? It sounds counterintuitive. Why explore the oceans when NASA's mission is to study the skies? But stay with me till the end of this journey to uncover the fascinating reasons behind NASA's ventures into the deep blue. And trust me, you won't want to miss what we're about to explore. Stay tuned till the end of this video to learn more. Before we dive into the why, let's address the how. NASA's connection to the ocean may seem surprising, but the agency has long held a dual fascination with Earth and space. In fact, NASA studies Earth more than any other planet through its Earth Science Division. The ocean, which covers over 70% of our planet's surface, is a critical component of Earth's climate system. Its depths remain one of the least explored regions on our planet, holding countless mysteries, just like space itself. As amazing as it is to think about what lies beyond the stars, the depths of our oceans are still incredibly unknown. In fact, some say that the deep sea is as alien to us as the far reaches of the solar system. Could something from beneath Earth's oceans hold the key to unlocking the mysteries of space? That's one of the many questions driving NASA's interest in ocean exploration. NASA's oceanic missions are often guided by the philosophy that understanding our oceans can help us better understand space. The ocean and space are, in many ways, two sides of the same coin. Both are vast, dark, mysterious, and teeming with life we know very little about. The technologies developed for space exploration, such as submersibles, rovers, and advanced sensors, are incredibly useful for underwater exploration as well. For instance, take the technology behind autonomous underwater vehicles, AUVs. These high-tech machines designed by NASA engineers can operate in extreme environments, both underwater and in space. AUVs are critical for gathering data from the deep ocean where human divers cannot venture. They operate in environments with crushing pressure and zero sunlight, much like the conditions on distant planets and moons. The same robotic technologies that help us explore Mars or map the surface of the moon are also helping us explore the mysteries of Earth's ocean floors. In fact, NASA's team is working on developing submersibles that can one day be sent to explore the oceans of other planets, such as the ice-covered oceans believed to exist on moons like Europa and Enceladus. It's a prime example of how space and ocean exploration are intertwined, and it's all thanks to NASA's commitment to pushing the boundaries of what we know, whether it's beneath our oceans or beyond the stars. One of the primary reasons NASA is so deeply invested in ocean research is because the more we understand Earth, the better equipped we are to understand other planets. Earth's oceans play a crucial role in regulating our planet's climate, acting as a giant heat sink and carbon store. By studying the ocean's dynamics, NASA scientists hope to improve climate models, predict future changes, and even help with the search for life on other worlds. This leads us to one of NASA's most ambitious oceanic projects, the study of hydrothermal vents. Deep under the ocean, where sunlight never reaches, hydrothermal vents release scalding water rich in minerals from Earth's interior. These vents support entire ecosystems that thrive in the absence of sunlight, where life is sustained not by photosynthesis, but by chemosynthesis, a process that converts chemical energy into biological energy. These deep-sea ecosystems are fascinating to NASA because they serve as analogs for potential life on other planets. Could similar hydrothermal vents exist under the icy crusts of Jupiter's moon Europa or Saturn's moon Enceladus, supporting alien ecosystems? NASA certainly hopes so, and they're using Earth's oceans as a testing ground to figure out how life might survive in such extreme conditions. As mind-blowing as it sounds, NASA is using Earth's oceans to prepare for the search for extraterrestrial life. The oceans on Earth may offer clues about what we could find in oceans beyond our planet. Take Europa, for example, a moon of Jupiter that scientists believe harbors a vast subsurface ocean beneath its icy shell. While Europa's ocean is covered by miles of ice, it's possible that hydrothermal activity, just like Earth's hydrothermal vents, could exist beneath that ice, creating conditions that could support life. NASA's Ocean Worlds Exploration Program is designed specifically to understand the habitability of such environments. If life can thrive in the harsh, pitch-black, high-pressure environment of Earth's hydrothermal vents, it's plausible that similar forms of life might exist on other ocean worlds. The instruments and technologies being developed to explore these extreme conditions on Earth are essential for future missions to these distant worlds. For instance, NASA's BRUI, Buoyant Rover for Under-Ice Exploration, is being tested in Earth's polar regions, under the thick ice of Antarctica, to simulate the conditions that might be found on Europa. This is just one example of how ocean exploration on Earth could one day lead us to discover alien life beyond our planet. While the search for life is one of the most exciting aspects of NASA's ocean research, it's not the only reason for their deep-sea explorations. NASA is also deeply invested in studying the ocean because of its impact on global climate. The ocean absorbs about 90% of the heat generated by global warming, making it a critical component of predicting future climate trends. NASA's satellites and sensors are essential for monitoring ocean temperatures, sea level rise, and the melting of polar ice. For example, NASA's ICESat-2 mission measures the thickness of polar ice with unprecedented accuracy, and the Aqua satellite monitors Earth's water cycle from space. These missions are critical for understanding how the ocean is responding to a changing climate, and how those changes are affecting weather patterns, marine ecosystems, and human communities. But did you know? Over 30% of the carbon dioxide emitted by human activities is absorbed by the ocean? This process helps mitigate the effects of climate change, but it also leads to ocean acidification, a phenomenon that harms marine life, particularly organisms with calcium carbonate shells, like corals and shellfish. By studying these effects, NASA's Earth science missions are helping scientists predict the future impacts of climate change and develop strategies to mitigate them. NASA is also contributing to the mapping of the ocean floor, a task that may sound mundane, but is critical for many scientific endeavors. Less than 20% of the ocean floor has been mapped with high resolution, meaning the remaining 80% is an unknown expanse, hiding geological wonders, new species, and potentially valuable resources. To map the ocean floor, NASA uses advanced technology like radar altimeters and LiDAR systems, the same technologies used to map extraterrestrial landscapes. These projects have revealed incredible undersea features like mountain ranges, volcanoes, and deep trenches, providing essential data for scientists studying everything from earthquakes to underwater ecosystems. And there you have it, a glimpse into why NASA is diving into our oceans. If you're fascinated by the mysteries of the deep ocean or the endless possibilities of space, I encourage you to follow NASA's latest research. And before exiting, make sure you like, share, and subscribe for more exciting content. And who knows, maybe one day, the clues we find in our oceans will lead us to discover life in the far reaches of space. Stay curious and keep exploring.